sometimes we have integrals like this that don't just have an x at the front, but as you can see in this particular one, x squared. We make this part u and we make this part dv by dx. So when we're integrating by parts using the formula above here, what we would get would be our u part, which is going to be x squared, put that in brackets, then multiply it by v, and v is the integral of dv dx with respect to x. So I need to integrate e to the 3x with respect to x, and that would be 1/3 e to the 3x. Okay, I make no attempt to simplify this term, just simply put the v part in the bracket. Why? Because all we've got to do is now just simply do minus the integral of v, which will be everything in this bracket. So we just put 1/3 e to the 3x, and then we just need to multiply this by du by dx. So we need to differentiate with respect to x the u part here. So differentiating x squared is 2x. And then don't forget to put dx on the end. So I've done my integration by parts using the formula here. What I next do is to simplify now each of the two terms. So the first term could be written now as 1/3 x squared e to the 3x, or if you like, x squared over 3 e to the 3x. And this term here, well, cleaning it up, I can see that I've got 2/3, and so I'm going to put that out the front of my integral, 2/3. Always a good thing to do, put constants out the front of integrals when you have a common factor. And then what I'm left with is x times e to the 3x. So we'll put that down as x e to the 3x, and don't forget that dx again. Right, now when it comes to integrating x e to the 3x, you'll notice that again I've got a product of two functions that I cannot expand. So I'm going to need to use integration by parts again. So I'm going to call the x my u, and my e to the 3x, that will be dv by dx. And we start, as I say, all over again. I write the first term in, x squared over 3 e to the 3x, and then minus 2/3, and because I've got it out the front of the integral, it's going to make it a lot easier to handle. I just put a square bracket up here, and all I need to do is just do by parts again then for x e to the 3x. So it's the u part, which will be x, times v, which is the integral of e to the 3x with respect to x. That's going to be 1/3 e to the 3x. Keep that in brackets, again making no attempt to simplify that, minus the integral of v, so I just copy that bracket straight in, 1/3 e to the 3x, multiplied by du dx, the differential of my u part, differential of x then is 1, okay, dx, and then close the bracket. Clean up, okay, notice you do something and then I clean up, okay, so first term is already cleaned up, that's x squared over 3 e to the 3x. Now when I clean this up, I'm going to multiply at the same time each term in here by the minus 2/3. So minus 2/3 times this term here is going to be minus 2/9. So put that down, minus 2/9 x e to the 3x. Alright. And then we have minus 2/3 times this 1/3. And remember there's a minus here, so it's going to be plus 2/9. Okay, 2/9, and then we have the integral of e to the 3x with respect to x. Now all I need to do is integrate this last term, so we have x squared over 3 e to the 3x. I'm just going to copy these two leading terms down again, minus the 2/9 x e to the 3x. And then if I integrate e to the 3x, that's going to be a third e to the 3x. And if I multiply it with the 2/9, we're going to have 2 over 27 e to the 3x. And don't forget the constant of integration plus c. And essentially that's the answer. What we could do though is simplify it further, which I think is a good habit to get into. And if we simplify this, we look for lowest common multiple of the 3, the 9 and the 27. So that's going to be 27. So I'll bring a 1/27th, if you like, out the front of a bracket. Are there any common factors across these three terms? Well, there's an e to the 3x, so I could put an e to the 3x up there. And so that means that what goes in here for the first term, we would have to multiply the 3 with a 9 to get 27, so I need to times the top by 9, and that will give me 9x squared. To turn 2/9 into 27ths, I would need to times the 9 with 3, so I times the top 2 with a 3, so that's going to give me 6. So I'd have 6x. Remember, the e to the 3x is out the front. And when we come to this term, it already is in 27ths, so I can just simply have plus 2. And then don't forget your constant of integration. Here we have a quadratic, and this quadratic factor, does it factorize? Well, you could try it on the side on a scrap of paper, but the quadratic doesn't factorize, so I'll just leave it like that. And there you have the integral then of x squared e to the 3x by parts gives us this answer.